Hi guys, this is lecture 2.2 and today we're going to be talking about the derivative of polynomials and constants. Let's start the lecture by explaining the constant multiple rule. This rule states if we have a function f of x equals to k times g of x, where this k is a constant number, then the derivative of f of x will be equal to k times the derivative of g of x. Now let's try to prove this constant multiple rule. We're going to start with an expression that we have already learned in the previous lecture for the derivative of f of x. We know that f prime x equals the limit as h approaches 0 of f of x plus h minus f of x over h. Next, what we do is every time we see f, we replace it by k times g. What we can do next is we can take k out of these two terms because in the following step, we can take k out of this limit. You may notice by now that on the right side, we have the derivative for g of x. Therefore, the derivative of f of x equals to k times the derivative of g of x. Next, we have the constant function rule. If we have the function f of x equals to k, where k once again is a constant, then the derivative of f of x will be equal to 0. The proof for this is very simple. Once again, we start out with the same expression for the derivative of f of x. We know the derivative of f of x equals to limit as h approaches 0 of f of x plus h minus f of x over h. Now we replace both of these terms by f of k because the function is constant and it doesn't change. F of k minus f of k is equal to 0. We'll get 0 over h, which is equal to 0. Now let's take a look at the power rule. If we have the function f of x equals to x to the power of k, where k is a real number, then the derivative of f of x will be equal to k times x to the power of k minus 1. Let's try to prove this. Once again, we start out with the same equation. Next, we have f of x is equal to x to the power of n. Therefore, we replace f of x plus h by x plus h to the power of n, and we replace f of x by x to the power of n. Now what we do is we take out x plus h minus h from this expression. And what we're left with is this rather complicated looking thing, which can be reduced later on. But if we just look at the front for a moment, we have x plus h minus x. That's essentially h. So we get h over h, and the two h's cancel out. Now we're just left with this whole thing that's rather complicated looking. Next, you may notice that if we put h is equal to 0, all the h's will cancel out. So then we're left with this expression that looks like x to the power of n plus 1 plus x to the power of n plus 2 times x, so on until the x to the power of n minus 1. X to the power of n minus 2 times x is equal to x to the power of n minus 1. So what we're left in this equation is n numbers of x to the power of n minus 1. Therefore, the derivative of f of x equals to n times n to the power of n minus 1. And that's the end of this lecture. Thank you guys for watching. Remember that practice makes perfect, so please do your end of chapter questions as well as your assignment, and I'll see you